I just wanted to show some upgrades I did to my web server here. Let me see. You can see a light in here. You can see those two cards right there. Those are actually NVMe adapters I bought, $5 each on from China. Let's see. You can see inside of them are little M.2 cards. Those are SM. They're Samsung SM951 NVMe edition, because there's a AHCI edition. Obviously the NVMe is much faster because that's the one that has geez, I can't get the light working. That's the one that has the NVMe interface instead of the standard SATA interface. So anyway, that's what I'm now running my database and web server files off. Those are 256 gig ones. They're super fast. NVMe, the interface is just much faster than SATA. So I'll show that in production. This thing is open right now, so that kind of is relevant to what I'm about to do. I'm going to show how it runs. And one issue with these NVMe drives, or at least with the SM951s and the Samsung 950 Pros, is they do thermal throttling. So if you run them, they start to heat up and start slowing down. So I'm going to just run that one for a little bit, right? It was about, that's 1.2 gigabytes per second write speed. Let's run it again, a little bit longer. So the write speed, I'm seeing about 1.4 around, like when it's cool. Right there, all those blinking, I'm assuming it was doing some database stuff, so it's like heating up. But basically, if it writes too much, it starts to heat up and it throttles down. I've seen it go down as low as like, I'm thinking 400 megabytes per second, but I don't remember. Probably haven't seen it that low, unless I'm really running, this benchmark over and over. But yeah, you'll see I'm gonna cancel it out. There it was at 1 gigabyte per second, so it's still kind of the same speed. But it'll get pretty slow. Like it'll get down to 9. I mean, not relatively. It's still super fast. It's faster than any other SSD out there, or combination of SSDs and RAID. Like you could probably get that speed if you had multiple SSDs, but you wouldn't have the latency of just having a single. Well, those are mirrored, but a single drive like that. So latency is super good compared to SATA, because the interface is much simpler, and there's I think it's like way more queues. Like there's 32 or 64 queues compared to SATA, which is like 1 or 2, something like that. So yeah, there you go. It's starting to throttle. You can see it's at 825 megabytes per second. Still super fast, but obviously it's something you could think about. I've seen some people who did who like have fans aimed at their drives so that it doesn't slow down. Now I'm doing a read test now. Let's see, the read and write I'm getting about the same, so it's kind of just limited by the chips, I'm assuming. You'd think write would be a little bit slower, just because SSDs in general are slower writing. So that's pretty fast. That was 1.7 gigabytes per second. I don't know if that's real or if that's just cached in RAM. I bet you if I do it again, it'll be even faster because it's cached now. Just cancel it out. Yeah, 1.9. But anyway, I don't think you'd get that normally. It's probably just caching it because I'm putting the file in. But anyway, yeah, you can see they're super fast. Latency is really low. It's really good for databases. I'm gonna just delete that temp file, and then I'm gonna do. So here I have my NZB database running. This is for this site, like index NZBs. Yeah, and the site, I'm not sure if it's actually running faster. I was already running on an SSD, like kind of an older one though, so now I'm running on like one of the fastest things I could find. So definitely doesn't seem like it's slow, but this site also caches stuff too. It uses Sphinx. I think it uses Sphinx to cache stuff, which is like a database caching middleman between MySQL. So MySQL isn't always running the query yet. If I keep clicking this All Movies button, it's just going to ask it from Sphinx. But if that one might be cached as well. But let's see. Let's do All TV. There, it might have actually had to run the query. So, or let's do a different page. So when I do like some random page, I actually had to run a query there. It still is pretty fast. Let's do that for movies, like something really old. There you can go. There you go. You can see it's loading. So it had to do a query for that page. So it's still pretty. So that's pretty fast actually for when I compared to when I had this running on a regular SSD. So definitely seems to be faster. Let's go out of here and show a top. You can see there I'm using about 100, like 2.5 threads of MySQL. It's ramping up now because whatever query is running on my in my tmux window. Yeah, it's using a 600% CPU, so it's about. So this can you know go up to 800, which is how many cores I have in this system, because it's a Xeon 1230 V2, so it has 4 cores hyper-threaded, so 8 virtual cores. So I can go up to 800%. That's CPU usage, and if I click M, it shows I/O. You can see I/O is all 100% MySQL. So I don't know how that actually counts that. I don't know if it's just saying 100% of the MySQL being done is by this process, or if it actually means the drive is being maxed. I have a feeling it doesn't actually know the speed of the drive. It's just saying of the process, of the I/O I'm doing, this is how it's getting split. So kind of useful, but not that useful compared to the CPU thing, where the CPU actually tells you, percentage of the available. Anyway, just showing my NVMe SSDs. They cost me $140 each. I bought 3 of them, but there's 2 in that system, 1 in my laptop. So I bought 2 of them, bought the adapters for $5 each from China, and everything's working well. And that's my new super fast database web server. I mean, I don't think there's any reason to upgrade at this point. It's pretty much as fast as I could get it. So, all right, I guess I just got to find more applications to run on that thing eventually. So anyway, see you guys later.